Good evening, everyone. Hello, Zohar.
Hi, Ariel. How are you?
I'm great. Great to see you.
Great to see you too.
We are planning to start in just a few minutes. We'll let a few more people to register to join in, and we'll start with our exciting talk for tonight.
Ariel, maybe we should put on some music for the crowd not to be bored.
Exactly. I thought about it. You know what? Probably we can start. There's not great music. I mean, I can put mine, but I'm not sure it's going to be great. So perhaps we can start, Zohar. What do you think?
Let's go for it.
Perfect. So hello, everyone, and thank you for joining our talk for today. So I'm Ariel Shuper. Together with me is Zohar Kaufnam.
Hello. Hello to all the crowd.
Thank you. So Zohar is VP R&D and CTO in Portif. I'm Ariel. I'm product management in Portif. And what we want to talk to you about is security misconfigurations in containers and Kubernetes clusters deployment. Sounds like a interesting topic, complex, a lot of details. So stay tuned with us. We prepared a great demo to show and to simplify the topic. Zohar, are you ready?
Yes, and may the gods of the demos be with me today.
Thank you. Certainly hope so. So what we're going to talk about? We're going to talk about security misconfiguration. We're going to highlight the different risks. We're going to cover, recent attacks that happened due to those misconfigurations. We'll show some live examples. Then we'll talk about security misconfigurations in images, how to detect it, when to detect it, and most important, how to mitigate it. We'll move to the next phase in our life cycle, the deployments. We'll talk about misconfiguration in deployments. And again, we'll talk about what can go wrong, how can we detect it, and more important, how we can mitigate it. And the top is left for the end, of course. Whoever's going to stay with us. We're going to talk about security misconfiguration in clusters. We'll highlight recent attacks that generate out of headlines. And we'll also show some interesting tools, open source tools that can show and emphasize live potential attacks that can happen any day, anytime in those locations. So stay with us. We'll promise exciting demos. All right. So let's start. Let's talk about what can go wrong, why we need configurations. And in discussing what can go wrong, a lot of things can go wrong. Zohar, when we deploy cluster in Portif, what are the main things you put your focus on?
So that's a good question. Usually we look, at various aspects, and there are lots of them. We look at the vulnerabilities of the pod. We look at the security context. We look at the runtime attributes like permissions, role-based access controls, and also there are many others that we will cover today.
Exactly, and these are great points because Kubernetes was really designed to simplify and to speed application deployments. It has tons of configurable options. Now, all those options, of course, are great. They are built-in tools, but they must be taken care of. You need to look at them carefully. You need to make sure when you deploy them in the right thing. So you touched about the network policies. By default, Kubernetes does give you a great tool to decide who can communicate with who, but by default, everything is left open. Any pod can communicate with any pod because there's no policy attached to those pods. And the same thing relies to the security context, for example. Security context is that touched it, how you deploy your pods, what privileges, do you allow privilege escalation, what volumes you mount, all those default settings, those are great tools to help you to manage and get better security. But if you leave them by default as is, you can get, the most unsecure deployment, and you can open the biggest doors to any potential attacks. And we didn't talk about secrets. Everybody think, secrets are great. No one puts secrets hard-coded in their images. That's correct. But how many Helm charts or how many deployment files we discovered in, like tools like Helm, like the chart center? How many charts there has, tons of passwords that are exposed in plain text that everyone just, can put their hands on and use. Config map. A lot of those things, are great tools, but without the right attention, you can get serious damages. So, it's not like something we talk about out of the blue. When you examine the recent attacks that were public, you can see many of them in live examples. So, in about a month and a half, Azure Security Center discovered a crypto mining campaign on Kubeflow users, just because users forgot the dashboard. I mean, not forgot. I think deliberately open the dashboard for external access, so they can access and can play with the configuration, bring in more pods, remove more pods, and play with their artificial intelligence measurements. And as a result, hackers were managed to use this applicative dashboard and run out a huge crypto mining campaign, right? I think about a month before, they discovered just exposed dashboard that, again, crypto miner users used to run lots of or large replica sets of crypto mining. So obviously, exposed dashboard probably can be, the number one potential. I think it was started back, 2018 when Redlock discovered, as you can see on the left side, the lessons from the crypto jacking attack on Tesla. But even in 2020, after the industry and the users become more mature and more aware of it, so maybe Kubernetes Dashboard by itself not exposed anymore, but just applicative dashboard that has a lot of power, do many things, are still left exposed, would give potential attackers a way to deploy, or run multiple jobs or multiple crypto mining containers. And we'll show you like a simple open source tool that can, show you all those exposures instantly and very easily. But dashboards by themselves are not the only pitfall or not the only thing. If you remember, not recently ago when DigitalOcean presented their Kubernetes service, there's a very nice, article about how you can hack DigitalOcean Kubernetes services. And those adjustments of privileges and etcd, which was the image metadata, which was exposed with different applicative attacks. Now, the interesting thing I think that can bring us to conclusion is the attacks didn't change. It's the same attack, just the exposure, the more elements, the more items which are exposed allow users to leverage, existing techniques, but to gain bigger footprint and to get more exposure to Kubernetes services. And analyzing those attacks and the root cause of those attacks and the importance of putting the emphasis on the right configuration and what's need to be configured. And I think it's not just us that discovered it. I think it's probably kind of a known paradigm today in Kubernetes security that a lot of those attacks or a lot of potential pitfalls can be avoided only if the right security settings were in place and if those were detected or the risks were detected in advance. And this is something that won't bring us to our next slide, which is, let's talk about all those misconfigurations. And we're just going to follow the different stages in the deployment. When you start creating an image, moving up to deployment, and then running it as a container, we'll just follow those stages and go step by step and see what can go wrong, what's need to be secure, and more importantly, how you detect it, what you can do, and what will be the best way to prevent it. Great. So Zohar, what can you tell us about images? what can go wrong in images? What do we do in Portif in order to verify it doesn't go wrong?
So actually, there are a few things. First of all, there is also the configuration of the Docker image. There is a benchmark called the CIS benchmark. We are checking, every aspect of the image, looking into various things, and that we'll see in a moment in the demo that might be wrongly configured, and helping the users to strengthen the security posture of their images. This is, of course, on top of the various vulnerabilities that might be already inside the images, and of course can be also spotted and remediated. So usually we recommend that you use verified packages from trusted sources. Downloading an image from the internet and just running it can be very, very dangerous, because you don't know who wrote it, and maybe they put something malicious in it. If there is no need for a specific package to be inside the image, it is better for it to be omitted from it, because in the future, maybe it's okay, but in the future you might find vulnerabilities and other security aspect in this package that will be a gate for a potential attack. We also scan for, like Ariel said previously, for secrets. Sometimes users forget secret inside their images. You would like, before these images are deployed or even uploaded to a public registry, to be scanned and to verify that there is no secrets that are residing inside this image. And lastly, you want to verify that a user will not become root by incidents. So a popular way to do that is having a set UID or set GID permissions. So once you run this executable, you might become a root user. So all these aspects can be scanned, can be verified, and we can alert the relevant developers in the CI phase, when they create the images, totally shifting left from just discovering this during runtime or just a second before runtime.
Great, thank you, Zohar. I think this is great, really, really important feedback that people should know. I think today the notion of everyone that, scanning in CI is focusing on vulnerabilities, right? Vulnerabilities is critical, vulnerabilities is important, no doubt about that. But I think you touched on many security best practices that, are really, I wouldn't want to kind of underweight them, but I think are not less important than any other of those vulnerabilities, as you mentioned, removing set UID or set GID, which, could be really painful if someone can leverage them. And as you said before, sometimes you look at your image, it really, really looks very, very small, but with all the dependencies and all the different, packages which you call, it can turn into huge. I remember I saw a demo a while ago that like a small image, 78 lines, bring behind it, 1,500 lines of, all the different packages and dependencies. And again, just because, it's there, people tend to use it. And I think, looking at all those aspects which you're saying, on top of course, scanning for vulnerabilities is really, really great, or at least great from security perspective. And important to note, to do it, before. And as you mentioned, doing it, in the automation part, doing it as part of the CI is absolutely a must. And I'm jumping into this demo. What can you tell us about this demo? What do you do, in CI pipelines? How do you automate this security?
So what we will show now is a plugin, a Portif plugin that scans actually scans all the CI images. So let me share my screen. So you can see here a black screen with lots of letters on it, very small ones apparently. So let me try to make them bigger. So here you can see that we are scanning an image. This in this case from Docker IO Nginx 1.10, and it will take around a minute. So in order not to bore you, this is the results of the scan. I have prepared them already. So this is again the same image, Docker.io Nginx 1.10. So let me make the results bigger. So as you can see here, there are few items, nothing critical, because Nginx, there are people that take care of securing these images. But there are also here some recommendations. For example, to create a user for the container that will not be root, for example, enable content trust for Docker, add health checks, and also look at the various files that have the setuid or setgid attributes in order to verify that everything is okay. So this is an example of a container that here are the results of the scan that we did now, of a container that is actually in good shape, but there are also others that are not in good shape. So this is an example of a scan that I just did previously of a container that has lots of items. So on the top you can again increase the font, so you can see lots of vulnerabilities and packages that need to be patched. If we concentrate on configuration, there is fatal errors here. For example, one used a copy instead of add in the Docker file, which might be dangerous. Or the credentials inside environment variables. For example, MySQL _ passwd. So this might be a password for MySQL database, which this is a secret that leaked inside the image. Another thing, that the apt-get caches were not cleared, so it's a good thing to clear them all before posting the image. There is a user without a password. So you can see here that various aspects need to be taken care of before actually publishing this image. So actually, such an image would fail in the CI phase and not even be uploaded to the registry.
This is really critical to talk about, that the ability of users to define a policy, when does he want, the image to pass and move to the registry, and when does he want it to fail, make the developers obviously fix it in advance. Many researchers just show how more efficient it is, if you want to fix things, on the right, when they happen, not to wait until they're being deployed. So automation and early detection are really, really critical, and you touch it again, about shifting left. This is really important. So thank you, Zohar. This is really, really a great demo, and really, really showing all the different aspects. So let's move on. Let's talk about, what can happen afterwards. So we're talking about deployment, talk about, images. Images are great, passing the CI, going to the registry, but then comes the day when everybody's getting excited and they're being deployed eventually. So we want to deploy the images into your cluster or into our clusters. And then comes the question again, what can go wrong? What do we do wrong? What we need to check? What we need to be aware of? So obviously, we touched about those best practices about the images, but we're going to deployment, and we can look at it again, some different typical Helm charts with hundreds of different lines consisting multiple elements. Now, it's really, very important to look at all those elements. Sometimes in the very, very rear and the bottom, at the end of those files are hiding some critical elements. So in those, deployment files like Helm charts, for example, all the security context of the pods, of deployments, of stateful set are really being set. Now, the security context sounds something like really, really cool, but, talking about, how you run your pods, are they privileged? Are they root? What volumes you want to mount to your pod. And I think the critical point here is to make sure that, no one is mounting the host path, or items like your access, if it's read-only or read-write to the file system. If your privileges can be escalated, so even if you run normally, if an attacker breaches in, all those security context aspects are really, really important, and you can see them in many different locations in the Helm charts. Now, Zohar, you touched about before about the roles and the role bindings. Give us an example. What can go wrong with roles or role binding? What are the things that users need to be aware of?
Yes, so we can show you a demo that we scanned during the CD. Let me share my screen again. So you can see here two scans, scan results of CD. Both of them were done using Helm. So one of them was, successful, didn't have many findings, while the other one actually failed. So we failed it during the CD, and because we found too many things. So if you, let's maybe increase the font here. Okay, hopefully it's not so readable, but I'll explain. So this is an Airflow package that is deployed, and this package has a few issues. It's a huge YAML file. YAML file is it's very hard to look at all the lines there and actually understand the issues. So if we just see the YAML file here on the screen, so this is the YAML file, and it has, like you see, a tremendous amount of lines. So this is a small deployment, so it only has 1,700 lines, but they are even bigger. And you cannot expect a human to pass on all the role-based access controls and anything else that is here and actually understand what's going on. So for that, we have computers that will pass on this for us and actually tell us that, for example, the security context of the resource Airflow web is actually allowing it to run as root. So this is it was not specified even in the YAML file. So even if I'm a reader and I read YAML files for breakfast, I cannot know that because just the parameter of which user to run as was omitted, and the default for some reason is to run as root or allow actually the pod to run as root. So this is not optimal, and this is what you see here on the first line. So we understand this, and we actually advise the user to force the running image to run as non-root. So this is something that should be specified in the security context. Another thing is, for example, we found out a secret. So you see here Redis password. So we can look again at the YAML file and search for that. So it's easier to search for such a variable after someone told us instead of reading all this long file. So you can see here the Redis password is used a few times in the YAML file. So it's actually a celebrity. And somewhere on the bottom of the file, actually, we can see that this is used for the Airflow Flower configuration. So let's look at the Airflow Flower configuration. So not the first one. So somewhere around here, maybe it's even a bit upwards. So remember, it's line 900 something. There is the secret that of the Redis secret here. So let's check for it. So here is Redis password, and you can see that the value here is password. which is not such a secure password, but we find that this is an environment variable that is used in the Airflow Flower container, and we of course alert the user that this is not a secure way to do deployments. So there are other aspects here that we scan and find. Some of them have no risks, so used correctly. So we just let the user know that they were looked for. But in general, we see that without such a tool that scans the CD, it's hard for the user to actually comprehend what's going on. And just a few words with your permission, Ariel, on security context, in case the crowd is not aware of what is a security context and why it's important. So a security context typically it's again a long YAML file, and typically it specifies a few attributes that are allowed or not allowed for the pod. The pod is just manifesting what is needed for it to run correctly. So, for example, here you can see that run as user must run as non-root. So this is a secure way that was omitted in the previous example that I've shown you. So here the pod is not allowed to use privilege escalation. It is mandated to use a read-only file system. Also, there is a very small list of volumes that is specified and can be accessed using this pod. So typically, this is a typical security context, and so it can be enforced using a pod security policy profile. In Portif, we are not relying only on the scans that happened during the CD. Sometimes mistakes happen even by changing the runtime environment in order to debug something or do anything else. So we actually can mandate that, for example, things that are running in a specific environment, for example, the production environment, would actually match a specific pod security policy profile. Here, the strict security profile I just shown you. So if the pod is not matching that, we can either not let it run, so block it from running, or detect it, meaning we will just let it run, but we will mark this pod as a violation or a non-compliancy issue and alert the users accordingly.
Thank you, Zohar. This is, I think, really great, a very important thing. Can you talk a little bit about, what we did in Portif, to simplify all the process? In Kubernetes, using pod security profile is a little bit complex. You need to define role and create role binding to your service account. So it's not necessarily always the most granular thing. Can you talk about a little bit, how you can really make it, granular, so you can apply different settings per container based on the sensitivity of it?
Yeah, this is a good topic. So actually, what's happening in our policy is that we have rules, and each rule actually is very granular. You can specify a specific environment, and for a specific environment, which containers or pods are actually allowed to run, and what are the security aspects that they must be compliant with. So if you remember the last screen that I've just shown, there was a line in English that actually you can read it. It says that in an environment named prod, which containers are allowed to run and which pod security policy profile they need to match in order to be compliant. So this is much easier than using huge YAML files that you don't always understand which profile is actually applied to which pods. And you can actually do lots of such rules in our UI and be as granular as you want. And these rules even have order. So you can mix and match, allow, detect, and block rules while understanding what will be what is the precedence of these rules.
Thank you, Zohar. That's really, really great. We got some questions from the audience, and I think it's in line with the thing we discussed. And someone is asking, you talked about many things can go wrong, or many things, which are important to detect, while you're running, your pipelines. And the question is, how do you block them? Okay, let's say you find something bad, doesn't match your policies, doesn't match best practices, doesn't match, what you want to do. What do you do? How do you stop it?
So actually, there are two I would say, methodologies to stumble upon such an issue. So the first one, is a tough one. You just block it from running. We have an admission controller, and this admission controller is actually blocking the pod from actually running in your production environment if it's not compliant. So the problem will actually not be in the runtime at all, but will be stopped just before the runtime, like a gate before the runtime. Alternatively, if you don't want to be that tough and you just want to be notified on or alerted on such issues, we can use the detect mode for each rule. This is where you can specify either block or detect or allow if you want also to allow things. So, and if it's detect, then we are just letting it run as usual. So if it's a production, we will not break the production, and everything will run as specified. While we will notify the relevant systems that are used by organization, either Splunk, OpsGenie, or Slack channels, or maybe others. And this way, they will learn that there was some non-compliancy item, and will mitigate that accordingly.
That, of course, can open a GR ticket. As the regular developers, but I also want to talk about, when you're running a pipeline. So you're doing all those scans in advance. You want to catch them in advance. And I think, users want to know what they do in the pipeline, how they can, stop it from being deployed there.
Of course. So we have also CI policies and CD policies. You can mention in these policies on which event would you like to stop the pipeline. So, for example, if I look at the CI and see a critical item, or maybe look at the CD and see a high severity item. So, on each case, I can decide what to do, and either I would like to alert, or I would like to fail the CI or the CD and stop them, because this is something that I will not allow to actually go to the successful ending of this process.
Perfect. And I think it's really, really important, that you can stop things at the, closer to where they happen, or closer to the one who is responsible for them, that he can really fix them quickly and probably more efficiently before he goes to a different task, and and forget about what he did, in the previous image. Like, what we see today, that images are getting stuck for a long period of time, and then we need to be fixed. Really take some time. So thank you, Zohar, for that. It was a great demo so far. The demo was really, really good, and showing educational things. Let's move to the next challenge. Now,
just let the crowd know that we saved the best demo for last.
That's correct. We give a heads up about it. That the best demo is coming for last. Wait a second, we have another question. What about images that are already running in a cluster? Oh, that's an interesting point. Can we do something about them? So first, I want to ask you an interesting question. When you're seeing images, probably people talk about images, people tend to think about their applicative images. What about what other images can run in the cluster, which not always necessarily come from your developers?
Yeah, this is a very good point, Ariel. So let's assume that the developer is running a certain container in production. So what actually can happen is that the other container might join this container inside a pod. So, for example, there are sidecars, like Istio sidecars, and also others. So it's a very useful thing to add sidecars to containers, and these sidecars must also be scanned and verified for their configuration, or otherwise there can also include problematic items. Another item is the init containers. So for each container, there is some initialization done by another container. So the other containers is running only a few seconds, but it takes only a few seconds in order to hack into your cluster. So if the init container is bad or malformed, or someone put malicious code inside it, it can do the harm in these few seconds, inject things that into the cluster, allow users to just log in without credentials or any other aspect. And so these init containers must be also verified for their configuration.
So what do you do? How do you scan them? Everything we talked about until now, we're talking about pipelines, talking about CI, CD. How do you scan those either elements that didn't come from your pipeline because you purchased a monitoring tool, or just someone put some a metric collection tool? And how do you touch those init containers that probably someone initiate them or try to manipulate? How do you do this kind of scanning? It's not part of what we discussed until now.
So this is a very good point about runtime capabilities. Would you like me to show it?
Yeah, if you can. It's not planned, but let's do it. I'll set up a demo. We'll talk about the runtime concept, the importance of scan images, not just in CI, but also at another touch point in the runtime in the cluster.
Of course. So would you like to show the slides first, or should we jump to the item?
Okay, so let's talk about it. Let's keep it in mind. Just trying to answer a question, and then we're going to show it in a minute. So we start talking about runtime. We talk about deployments. Things can change. We are dynamic nature. Things are deployed fast. Other things come from your pipeline because they're coming from applicative nodes, worker nodes. But other things are not necessarily belong to your developers. They came from third parties. They came because you want to deploy a cool Helm charts you found, or a nice tool that someone told you is really, really helpful. Now, when you deploy those elements in your cluster, there are many elements. There are more permissions which are granted. There are more users. You can certainly sometimes find many users with many permissions running in your cluster. And those dynamic nature of Kubernetes clusters can create many risks. I think we touched before the dashboard risk, what happened when those dashboards are really exposed, which is becoming more and more popular attack option. We talked about insufficient ingress policy, so who can access, who cannot, who can try to reach your services. We talked about overly permissive roles. I think we just talked about we didn't show it. Maybe it'd be interesting to talk about and give an example why not just cluster admin, but sometimes you can get a lot of permissions to do a lot of things that not necessarily really needed to your owners, or get owner with multiple role bindings. So all of a sudden you can see all the roles, maybe not as big, but the overall aggregated bindings create a super user. So I think we talked about them. We talked about the insecure deployment. So let's focus about the new things. How you can really show us exposure of services, exposure of elements, overly permissive elements which can be suspicious. We can suspect them being dashboards. What do you think about that?
Well, I don't need to think. I can show the crowd what we have in our system. So let's jump to the next demo. So sharing my screen again. Okay, so in our system we have a few dashboards running. So we named them conveniently with dashboard, but of course they can be named otherwise. So there is the infamous Kubernetes Dashboard that was open to the world 2 years ago by default, and many organizations have had this Kubernetes Dashboard, exposed. So this, since then the Kubernetes evolved and it's now much more secure. But on this, on the other end, so Kubernetes Dashboard, you see it here. It's a very powerful tool. You can do anything in the cluster if you have access to this dashboard. So you need to guard this access, very carefully. So by default now, you access the Kubernetes dashboard with a token. So you can see here I'm logged in with a token, which is much harder than just browsing without a password. And so you can see here, this is, for example, this Kubernetes dashboard. The problem with the risks factor with it is it's public facing, and it is the Kubernetes dashboard. You can also look, if you remember, we talked about the security context, of this pod. So it was hardened, and it's much more secure than it was. It ran as user 1001, so non-root. And it also denies privilege escalation. The read-only file system is enforced, so it's true here. There is only a limited number of volumes that are allowed to be accessed. So this is compliant with the strict security profile that we have shown earlier. So, but again, this is a very sensitive sensitive item in our system, and it's better, like I do here, to do port forwarding and then just browse to it using a localhost. So this is the more secure way. A less secure way is to open it to the world. So like here, like you see, it's public facing. So this is, I didn't intend it to be a public facing. This is a configuration error on my behalf. But so this is why you need to have few layers that will guard you. And actually, you can have a connection policy. So policy that will guard all your pods and look at all their connections and actually block access to this dashboard, so the Kubernetes dashboard pod, and also another dashboard that we will see in a moment, the Kubeflow dashboard. So both of them we can enforce that they will not be accessed from the external sources by a connection policy or network policy in its Kubernetes name. And again, this policy can mix and match block rules, allow rules, detect rules, and it's very generic. So it can be used for much more than just blocking this pod from connecting to the outside world.
Right. So I think this is really a critical point. The ability to detect that it's public facing, so the service can be accessed, and B, with just a simple rule. You can just block any powerful public facing elements, but then we can talk about the detection of the dashboard, which is also I think an important thing.
Yes, so we will see in a moment how we detect dashboards and why we find dashboards so dangerous. But just before looking at the role-based access controls that actually defines the dashboards and make them so dangerous, just want to introduce you to the Kubeflow dashboard. Again, you can see I'm browsing to localhost, so it's a secure way to browse this dashboard. But Ariel, would you like us to tell us about the recent vulnerability that was actually related to a Kubeflow dashboard?
Yes. So I think around middle of June timeframe, Microsoft published a warning, finding that there was a huge campaign in Azure against Kubeflow dashboard, because apparently what happened was that developers are using the Kubeflow application for AI training. They expose this dashboard so they all can access this dashboard from externally, from outside the cluster, so they can of course tune or fine tune their modeling, the data modeling. And what happened was that since as Zohar explained, dashboards are really powerful, in building up, spinning up more resources, creating larger scale, creating larger replica sets. What happened was that they were not only the developers were the one who accessing the dashboard, because with some very simple tools, apparently you can find exposed dashboards. So not just developers, but also many hackers apparently found those dashboards, and across many deployments in Azure, those dashboards were breached and running, crypto mining, Monero cryptocurrency, until it was discovered by the Azure Security Center.
So this is a very good point, Ariel. So we'll see such a tool in a moment. But just before that, we will show why dashboards are so dangerous. So like we said in the CD, when you look at all the permissions of some cluster, it's very hard to understand exactly what's dangerous and what's not. So it's better that a computer, a software, will analyze all this and actually highlight the dangerous things for us. So let's look, for example, at the Kubernetes dashboard here. So this is so you can see that we marked it as high risk, and we explain to the user why. For example, this dashboard. So you see it here, that this is the high level of the dashboard. So it can actually browse secrets. So secrets are the sensitive things in Kubernetes. It can look at config maps, and it can also and actually it utilizes the permission of the user that actually logged in to this dashboard. So if this user is a cluster admin, like we'll see here, this is me, and nice to meet you. So I'm Zohar, and this is I could see here I'm a cluster admin. So when I logged into the dashboard, they actually can do anything because of my role as a cluster admin. So I'm almighty, that's fine. But when someone logged in as me, then they can actually access anything in the Kubernetes cluster and do anything. There are also other roles here. For example, I would like to show the default role for Kubeflow. So you can see it's also marked as high risk. And you can see here, this is a typical role-based access control. So lots of permissions in it. Nobody can understand it in the YAML file. It's also hard to understand when you see it all in the screen. So we highlight the high items. For example, again, looking at all the secrets. This is dangerous because you can see the secrets of the cluster. And if you see here, this role, the default owner in Kubeflow, has a scope of cluster. So actually, this permissions is to see all the secrets of the cluster. Don't ask me why, but if you have access to Kubeflow, you can indirectly see all the secrets that are not related at all to Kubeflow. You can also look at the get list or watch all the config maps.
The thing is coming in the line below. This is like the jackpot.
Yeah. So Ariel, would you like to talk about it?
Yes, so I think the mutating webhooks, configuration validation webhooks, giving almost unlimited power to do anything, on the resources. And you can see, look at the amount of verbs. You can do almost anything, and the amount of resources is also unlimited. So this pretty much gives you the ability to change, modify any resource in the cluster. And I think this is really critical. And this is what makes the Kubeflow so dangerous for other people use this, or you can use it or manipulate, especially if the wrong hands get access on this mutating webhook. This can really be critical. But Zohar, so we come
as a good example of a mutating webhook, like we explained earlier. With a mutating webhook, I can add sidecars to the pod. I can change the init container, and this way I can really do harm.
And without the user even noticing it, of course.
Yes.
The user deployed it and has no idea about it. So it's really important. Zohar, we're coming close to the end of the session. Maybe perhaps let's talk about some cool stuff. How you can find it in the wild.
Yes. So it's you think about all this and say, it's very hard to hack into Kubernetes clusters. How can I do it? Nobody will hack into my cluster. But it actually is very easy. Surprisingly easy. So there are sites on GitLab that actually you can see here awesome Showdown queries. So Showdown is a tool in the internet. We will see it in a moment, that scans all the IP addresses and looks for actually holes. And for example, one of such holes, and we talked about dashboards, is the weave work dashboard. Weavework is, again, a very powerful dashboard. You can do anything in the cluster with it, and if you have access to it. And surprisingly, there are lots of Kubernetes clusters that have Weavework dashboard on them, and they are open to the world. So as you can see here, if I just use this query, so title Weavework scope and HTTP fav icon hash. So I'm looking at the icon that is available for browsers, and looking at its hash, and the hash is identifying specifically that it's a Weavework dashboard. So this is the icon that will show in the Weavework dashboard. So so this is Showdown, showdown.io. I've put here the string that I've taken from the other side. And as you can see here, there are lots of Kubernetes clusters out of here on the wild. We can see a map of the world showing where in the world are they. So some of them are in China, but many of them, actually most of them, in the US. And you can see that they have open HTTP access, for example. So without a user, without a password, I can just log into the Weavework dashboards. So I will not do it, with respect to the real owners of these clusters, but I can actually show you what the Showdown site has on these. So it can show me the exact IP address, the port that is open here, port 80, and if I'll browse to this IP address in port 80, so surprisingly, I will see an open dashboard. So this is dangerous. And a misconfiguration of a user can leave the dashboard open for lots of, for a long time without anybody noticing, and giving hackers or even someone that is not malicious but just curious the ability to look into your cluster and do actually anything. So this is why you need few layers of security. You should scan in the CI, you should verify the configuration in the CD, and you should also have runtime aspects that may block such things. For example, not allowing Weavework dashboards to be accessed from the internet. This is even if all the configurations are wrong. So hopefully this was good enough, Ariel. What do you say?
No, that's super exciting. I must say, an important disclaimer that, of course, we reported back about this exposure to all the different elements, especially to the big, ISPs that runs it. So we are trying to be ethical hackers. But I think, Zohar, it really touches the point. People expose dashboards, they don't pay attention to it, and they don't understand what the amount of damage people can access and it can lose. I think that was really, really a good example. It's not just, as a wild dream. It's really something that can happen to anyone. So this is definitely important. And we got some questions from the audience. Would love to get some feedback about it. Can we block those kinds of operations from the kubeflow, like changing secrets or deleting pods? This is something, how do you modify the roles, of a dashboard? How do you minimize it to the least privileges that are required?
Yes, so actually the kubeflow developers have their reasoning of why they did this all these items. Probably it's and I'm as a developer, I understand it. It's easier to just give me permissions to anything instead of just worrying what are the exact permission I need. So you can decide to harden the YAML file of kubeflow and change the role-based access controls there before deploying it, and see that everything still works. But this is sometimes hard because this file is a huge file, and making the exact changes is far from trivial.
Sometimes you need it. Sometimes you really need it because you need to access secrets. Sometimes you really need those things. So it's really delicate balance, and it's hard to do. So the best is, of course, to verify no exposure, verify as Zohar explained, how to harden the deployment, verify it's not running as a root, verifying. A lot of those verifications we talked about can eliminate the chance that it will be manipulated by unethical hackers.
Yes, and this is a good point. And again, I must strengthen the multiple layers of defense. Even if you have a role-based access control that is too permissive, and you decide that you want to run, you still have few layers of defense that can mitigate the risk.
Exactly. And Zohar, I fully agree with you, and I think this is the summary and the important lesson we want all the audience to take with them home. So obviously, we're talking about super, complex, a lot of tools which are available, but all those tools, all those different layers has to be taken addressed in different concepts or the different layers. Everything, it's the best way not to just leave everything at the end, but to, spread it across your life cycle and making sure that you configure everything properly, making sure you're verifying those security levels, not just once at a certain point, but it's a constant work. You need to start in the CI, you need to continue the CD, and of course, don't stop in deployment because many things can happen even if you passed all those checks with the right tool and the right thing. Because now someone changed, now someone managed to put his hands on your dashboard and changing all your deployment settings without you even noticing it. So I think we're coming close. If anyone has more questions, feel free. We're going to stay here online until we wrap up. I want to thank you, Zohar, for great demos. It was really productive. I think it was great showing all those tools and what can be done. And especially, I think the last demo showing it's not far-fetched. Can happen to many. Still was until a few minutes before we reported it. Thank you very much.
Of course, and just as a side note, we have also other webinars we already did on this channel. Some of them are showing advanced topics like API server firewall that can also be of assistance in such cases. This is not related specifically for configuration, but for the additional layers of defense. And we encourage you also to see the other items that we already uploaded to BrightTalk. So thank you all for all the audience. Thank you, Ariel, for the great presentation.
Okay, thank you. Have a good night.
Have a good night.